Before starting the next lesson, try this warm-up question. Complete the table of values for the equation y equals negative 5x plus 9. And then answer the question, is this direct or partial variation? When I substitute my x values into the equation and do the math, I end up with my y values. So if I do that for each one, I end up with a completed table of values. And since this does not go through 0, 0, but rather 0, 9, we can say this is partial variation. We've talked about graphing lines from a table of values and from an equation, and now we're going to look at something called linear systems. So we will first define what that is. So a linear system is when two linear relationships are being compared. If two linear relationships are graphed on the same grid, you can find the point of intersection. When solving problems, it is important to understand what the point of intersection represents. So, two main ideas here. You need to know what a linear system is. Basically, you're graphing two lines on the same grid, and you're comparing those two things. The point of intersection is where those two lines cross, and that actually means something in the context of problem solving. So let's clarify that with an example. Bob and Brian entered a readathon to raise money for charity. Bob's mom has pledged $35 plus $5 per book that Bob reads. Brian's mom pledged according to this equation, where A is the amount pledged and B is the number of books Brian reads. So we have two relationships going on. We have the relationship between the amount of money raised and the number of books that Bob reads. And the second relationship is between the amount of money raised and the number of books Brian reads. So we're going to make a table of values, make a graph, find the point of intersection, and then say what it means. I'm going to challenge you to pause the video and fill out a table of values for Bob and for Brian. Make a graph for each of them on the same grid, and then find the point of intersection. So Bob gets $35, that's his initial value, plus $5 per book. So he starts at $35 and each book gets $5. So when we go up by 2 books, we're going up $10. For Brian, his amount is 12 times the number of books. So he starts with $0 and it goes up according to the equation. So when I take my points from my table of values for Bob, I plot them, and this is the line I get. Remember to add an arrow to the line to indicate that it would keep going if we had a bigger graph. For Brian's amounts, I've plotted those on the grid. And again, I added an arrow because that is going to keep going and going and going. Now, a good practice is when you have two lines on the same grid, you should label them so that you know which is which. So what's the point of intersection? Well, it's right there. That's where the two lines meet. But what does it mean? Well, we have to look at the context of the question. So A is the amount of money raised and B is the number of books that they're reading. So at this point, this would be where they each have read the same number of books and they're raising the same amount of money. So if I look at the coordinates of that point of intersection, my x-coordinate is 5, my y-coordinate is 60, so the coordinates are 5, 60. So what does it mean? Well, when they read 5 books, they raise the same amount of money, $60. So the next example is Bertha sells sundaes. Her fixed costs are $12 for supplies, and it will cost her $1.25 per sundae for ingredients. She will sell the sundaes for $2.75 each. So we're going to have an equation and a table of values for the cost, an equation and table of values for revenue. That's how much money she's bringing in from her sales. We're going to put them both on a graph, and then we're going to figure out how many sundaes would it take in order to break even. So cost is how much money she's spending. Revenue is how much money she's making. So you can pause the video and fill out a table of values and try to do your best at making an equation. I'm going to use these variables, C for the cost, R for the revenue, N for the number of sundaes sold. So in the question it says her fixed costs are $12 for supplies and it will cost her $1.25 per sundae. So using that information I can come up with this equation for the cost. It's $1.25 for each sundae sold with the starting value of $12. Her revenue is going to be how much money she makes. So she's selling them for $2.75 each. So that would be 2.75 times the number of sundaes. I can use these equations to make my table of values. And that's what we get. So if you tried that and you didn't get these numbers, try to figure out where you went wrong, but you can also let me know and I can help. Okay, so now we're going to make a graph. I put the number of sundaes along the bottom because that is my independent variable. Cost and revenue are my dependent variables, so I just put them along the y-axis. I plotted my points, drew my lines of best fit, and I labeled my lines, put an arrow on each of them. So how many sundaes in order to break even? Well, what does it mean to break even? That means your cost and your revenue are the same. You're not making money, but you're not losing money either. But really, this is just my point of intersection, right here. They sell 8 sundaes. The cost is $22 and the revenue is $22. So cost and revenue are the same when they sell 8 sundaes. So I can answer the question, she will break even when she sells 8 sundaes. Practice questions are in your textbook. If you have any issues, please let me know so I can do my best to help.